In this lesson, we're going to explore rationalizing numerators and denominators of radical expressions. And in this first case right here, it's inappropriate to have a square root in the denominator of a number. So whatever the problem is or the issue is with the denominator, that's what we need to multiply the top and the bottom by. As long as we multiply the top and the bottom by the same number or the same term, then it's considered to be 1 because anything divided by itself is 1. So in this case right here, the problem is that we have a square root of 3 in the denominator, so therefore we're going to multiply the square root of 3 by the numerator and the denominator. So 9 times the square root of 3 is just 9 square roots of 3, because this being a whole number and this being a radical number. On bottom, the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is just 3. So it's easier to write the simplified form of this. Then we need to look and see that this can actually reduce right here. 3 divides into 9 3 times, so we would have 3 square roots of 3, not interfering with that inside radical. Sometimes there's some simplifying that can occur as we go along simplifying the denominator. And in this case right here, we see that we have a square root of 16, which we know is going to be 4. So if we want to, we can go ahead and say 2 times the square root of 4, which is going to, 2 times the square root of 16, which is 4. 2 times 4 is going to give us 8 in the numerator. Now on bottom, we know the square root of 9, but we do not know the square root of x. So the square root of 9 is just 3, but the x must remain underneath the radical. So when we do this, it just makes smaller numbers that we have to use to actually multiply, or even terms in this case right here, because all we're left with is the square root of x, which the problem is the radical. There's not a problem with the 3 on the bottom, it's with the square root of x. So we're going to multiply the numerator and the denominator by the square root of x. So in the numerator, we would have 8 times the square root of x, which is 8 square roots of x. And in the denominator, we would have the square root of x times the square root of x, which is the square root of x squared, which is x, and we have a 3. So we would just leave it as 3x. And for today's lesson, we'll just leave it in that form. Actually, there is some reducing that can occur with the x's, but we'll just leave it in this case, just because we're just trying to get our radicals out of the denominator. Now, if we have a fraction, the way to look at that fraction is, individually, you can look at that radical as with the 7x in the numerator as well as the 3y in the denominator. So we're going to multiply by the square root of 3y over the square root of 3y. So in the denominator, the square root of 3y times the square root of 3y is 3y. The square root times the square root, we can multiply that together because it's going to be a square root and they're the same roots. 7 times 3 is 21. X times y is xy. And again, for today's purposes, we're just going to leave our answer as such. Now, there's a problem that occurs when we have 2 terms in the denominator. So far, we've just had 1 term. And when we have 2 terms in the denominator, we have to multiply by what we call a conjugate. Now, the conjugate is derived from the denominator. You take the denominator with the 2 terms, and that's when we use the conjugate. And all you do is change the middle sign. So when we multiply by the square root of 3 plus 2 over the square root of 3 plus 2. So like I said, you take your denominator, change the middle sign, and that is your conjugate. So on top, when we multiply this out, we're going to have 5. We have to use the distributive property. We're going to have 5 times the square root of 3, which is 5 square roots of 3. And then we have 5 times positive 2, which is going to be positive 10. Now in the the denominator, we have to use the FOIL method. So when we say the square root of 3 times the square root of 3, we know that that is 3. Outside, the square root of 3 times 2, we're going to write as 2 square roots of 3. I usually write my whole number first prior to my radical. Inside, negative 2 times square root of 3 is going to be negative 2 square roots of 3. And then the last term is going to be a negative 2 times the positive 2, which is going to be a negative 4. Now, when we simplify this, there's nothing I can do with the numerator, so I'm still left with 5 square roots of 3 plus 10. In the denominator, 2 square roots of 3 minus 2 square roots of 3, that cancels, so I'm left with 3 minus 4, which is negative 1. Well, I can actually divide that negative 1 out, and that would give me negative 5 square roots of 3 minus 10. I have to divide both of those out, not just the first terms, but the second term as well. And that would be my final answer. In this last example, again, we have two terms in the denominator, so what we're going to look at is using our conjugate. So we're going to take the denominator and just change the middle sign only. And again, as long as what we do to the numerator we do to the denominator, we're okay. So when we use our distributive property, negative 8 times square root of y is negative 8 square roots of y. Negative 8 times negative 4 is positive 32. In the denominator, the square root of y times square root of y is going to be y. The square root of y times negative 4 is negative 4 square roots of y. Positive 4 times square root of y is positive 4 square roots of y. And the last term, positive 4 times negative 4 is negative 16. And again, what we're going to do is we're going to simplify this as much as we can. And what I'm looking at is the 4 square roots of y, negative 4 square roots of y. We can cancel that out. So in the numerator, we're left with negative 8 square roots of y plus 32. And in the denominator, I have y minus 16. And for today's lesson, we're going to leave our answer just like that.